All right, let's talk about what happens if we take the log of the product of two numbers. Okay, the log of the product of two numbers is the sum of the logs of those two numbers. Okay, now why? Why? This is where it's very important to understand the properties of exponents in order to understand the properties of logarithms. Now, if you remember, there's a product property of exponents, right? When we have two numbers with the same base, we can add their exponents, right? So when multiplying two powers with the same base, we add the exponents, right? So if we treat this m and n as powers of the same base, right, then you'll see that we just add the exponents, right? Because the log is the exponent. The log is the exponent. So the log of a product will be the sum of the logs, okay? Because the log is the exponent, okay? All right, so I have a little bit of a proof here, which hopefully you can go through. But again, if you understand the properties of exponents, it comes directly from that because the log is the exponent, right? And when we have a product, we add the exponents when we multiply things. All right, so let's do some examples here which use the product property. So I want to use the product. I want to rewrite each expression as a single logarithm. Okay, so I'm going to use this product property, and so this is telling me that the natural log, I can just multiply these two things together, right? I can just say that this is the same as the natural log of e squared times e to the 7th. Okay. Now, there I've done it. I've done exactly what the question asks me to do. Now, I could take this a little bit further because I know that the natural log of, I know that e squared times e to the 7th is e to the 9th, and then you can see that that's equal to 9. Okay. Now, we could also go back up here to this original equation, and you know what the natural log of e squared is. It's just 2. The natural log of e to the 7th is 7. So again, that way you also get 9. So you can kind of get a glimpse of why this works, all right? So let's take a look at a common logarithm. Here we have the common logarithm of 1/10 plus the common logarithm of 1,000. And we want to write this as a single logarithm. All right, so we have the sum of two logs, and our product property says that we can write that as a product. So we have that's equal to the log of 0.1 times 1,000. Okay, and that's it. We've done it. We've done what they ask us to do. Again, I want to take it a little bit further because I look at this and I'm saying, okay, well, I know 1/10 of 1,000 is 100. So this is equal to the log of 100, and that is equal to 2, right? So because that's the 2 is the power you would have to raise 10 to in order to get 100. Now let's go back up here to the original equation. This is really just this is 1/10, right? Which is 10 to the minus 1. So the log of 1/10 is minus 1. The log of 1,000 is 10 cubed, right? So the log of 1,000 is 3. So you can see we also get 2 just by taking the logs of the two, taking the two logs that we were working with, okay? All right, so let's do another one here. Now again, you can stop this video at any time, work on these problems, and then you can even fast forward if you think you got it. Fast forward through it and write down the answers. You just need to do what you need to do. So I'm just going to go through it. I know sometimes it seems like these videos get a little long, but okay, let's just go through this next one. All right, so again, we have the sum of two logarithms. We're going to write it as a product. So the natural log of 2x plus 3 plus the natural log of x is the same as the natural log of, and I'm going to write the x first. 2x plus, let's see, 2x, not 2 plus, 2x plus 3. Okay. Now I'm going to put parentheses around this thing so it's, it's clear that it's the natural log of that whole thing. Okay. All right. So, but, I'm done, really. That's all I needed to do. Now, you could also write this as 2x squared plus 3x if you wanted to distribute that x. All right, one more. We have the natural log of 2 plus the natural log of 5. Oh, actually, not the natural log. This is a base 10. This is the common log of 2 plus the common log of 5. So again, I can just combine those into as a product. Oops. Again, I'm trying to write the natural log. Natural logs are the most commonly used logarithm in calculus. So because in natural log makes calculus really easy. So people prefer to use natural logs. You'll see later on. But all right, so we're going to use the common log here. So it's the common log of 2 times 5, okay, which is the log of 10, which we know the exponent that we do have to raise 10 to in order to get 10 is 1. All right, so that takes care of example 3. And as you can see down here at the bottom of the screen, next thing we're going to cover is the quotient property. So I'll see you in the next video.